First of all, let's talk about the derivative of secant. When we did this before, what we did is we changed secant to 1 over cosine. And then we found the derivative of 1 over cosine. Well, 1 over cosine is cosine of x to the negative 1. So the derivative of that would be, think about the chain rule, negative cosine of x to the negative 2 times the derivative of cosine, which is negative sine. And I was okay with that answer. I'm actually still okay with that answer. However, when we add the more complicated integrals of secant, it will be easier for you if you know the rule as it's printed. Okay? That way that you get more familiar with it. So, this is the same as, if I separate that sine over cosine squared, I can separate it into sine over cosine, and I can separate it into 1 over cosine. So 1 over cosine is secant, and sine over cosine is tangent, and so this is the rule I want you to know. I want you to know that the derivative of secant of x is equal to secant of x times tangent of x. So it's like I'm giving you a couple new rules that we didn't already know. Okay? Alright. The derivative of tangent, I think you already know. Or you should. We've talked about it several times. What is the derivative of tangent? We could change it to sine over cosine, and then we could do the quotient rule. You end up with 1 over cosine squared or secant squared. So you know that rule, but I just want to remind you of that rule. Okay? So we've got this rule, the derivative of secant. We have this rule, the derivative of tangent. This was another one that you know already, or should. So what's the integral of secant squared? So if the derivative of tangent is secant squared, the integral of secant squared is tangent. Again, I'm just trying to make sure that you can get these rules in your head. Okay? Alright, the next one, again, we have talked about several times, but I just want to make sure it's with all these others and that you start memorizing the rule. Okay? What we did when we found the integral of tangent is we changed tangent to sine over cosine. And then we did u substitution with the bottom. So du is negative sine of x, which means all I'm missing is the negative. So we have negative integral 1 over u, which is negative natural log of u or natural log of cosine of x. So, again, we have talked about that one, but let's make sure we start memorizing that rule. Okay? Last one, which we have not talked about, is the integral of secant. This is not a common way to solve this problem. I want to show you where it comes from, but really I just want you to memorize the rule. Okay? So, very cleverly, what they do to solve this integral is they take secant and they multiply secant by secant of x plus tangent of x over secant of x plus tangent of x. Where does that come from? Well, somebody's realized that if they do that, it'll work it out, and you'll be able to solve it. Okay? And secant of x plus tangent of x over secant of x plus tangent of x is 1, so I've not changed the problem. Okay? So what you do next is multiply out the top. Alright? So we have secant squared x plus secant x plus tangent of x. Let's make this look more like a plus. Over, that's still not a plus, sorry. Because I'm multiplying secant times secant and then secant times tangent. So that's secant times tangent. Alright, so all I did is I multiplied out the top. Okay, the reason that this works is because now what if I let you be the bottom? If I use these rules that I just gave you and that I asked you to learn, what's the derivative of secant? So that's the very first one I showed you, secant tangent. And then what's the derivative of tangent? Secant squared. Ta-da, look at the top. That is what the top is. So it's 1 over u. So you get the natural log of the bottom. Okay, that's the 5th rule I want you to learn. You don't necessarily have to be able to work it out the way that I worked it out. I just wanted to work it out to show you where it comes from. Okay, so the problems that you're going to be doing related to this is I'm just going to give you like a derivative of tangent of 3x and say find the derivative. Or I'm going to give you secant of 5x and find the derivative. Or I'm going to say x over secant of x. So it's things that involve secant and tangent where you just have to know those 5 rules. Okay? So these problems, the first 2 are derivatives and the second's integrals, and it's just using those 5 rules. You still might have to use chain rule or product rule or use sub or whatever, but it's using those 5 rules.